Great. So as I said, I'm Jason Flax. I'm the lead engineer of the Realm Cocoa team, potentially soon to be named the Realm Swift team, but I will not go into that. It's raining outside, but it smells nice. So let's begin the presentation. So here's today's agenda. First, let's go over what is an architecture. It's a very loaded word. It means a number of things. For developers of any level, it's an important term to have down pat. What are the common architectures? There's going to be a lot of abbreviations that you hear today. How does SwiftUI change the playing field? SwiftUI's two-way data binding makes the previous architecture somewhat moot in certain cases, and I'm here to talk about that. And comparing the architectures and pretty much injecting into this, from my professional opinion, what the most logical architecture to use with SwiftUI is. If there is time, I have some bonus slides on networking and testing using the various architectures. But if there is not, I will defer to the Q&A where you all get to ask a bunch of questions as Shane had enumerated before. So let us begin. What is an architecture? x86, PowerPC, ARM. No, it's not. This is not. We're not talking about hardware architecture here. Architecture is short for an architectural pattern. In my opinion, hardware is probably too strong of a word. Or architecture is too strong of a word. It's just a term to better contextualize how data is displayed and consumed. It really helps you organize your code. In certain cases, it enhances testability. In certain cases, it actually makes you have to test more code. Basically, the patterns provide guidelines and a unified or united vocabulary to better organize a software application. If you just threw all of your code onto a view, that would be a giant mess of spaghetti code. And if you had a team of 20 people all working on that, it would be fairly miserable and at a minimum, highly disorganized. The images here, just MVC, MVVM, Viper, MVI. These are the main ones I'm going to talk about today. There are a number of architectures I won't really be touching on. I think the notable missing one from this talk will be clean architecture, which I know is becoming somewhat big, but I can address that later in the talk or in a Q&A. So let's go over some of those common architectures. So from the horse's mouth, the horse here being Apple, the structure of UIKit apps is based on the model view controller design pattern, wherein objects are divided by their purpose. Model objects manage the app's data and business logic. View objects provide the visual representation of your data. Controller objects act as a bridge between your model and view objects, moving data between them at appropriate times. So going over this, the user uses the controller by interacting with the view. The view talks to the controller. Generally, controllers are going to be one-to-one with the view. The controller then manipulates the data model, which in this case, generally speaking, would actually just be your data structures / the data access layer, which could be core data or realm. The model then updates the view through the controller, is displayed on the view, the user sees it, interacts with it, goes in a big circle. This is a change from the original MVC model. I know there are a few people in this attending right now that could definitely go into a lot more history than I can, but the original intent was basically all the data and logic was in the model. The controller was just for capturing user input and passing it to the model, and the communication was strictly user to controller to model to view, with no data flowing the other way. This was like the OG unidirectional data flow, right? But over time, as the MVC model evolved, controllers got heavier and heavier and heavier. And so what you ended up with is MVC evolving into these other frameworks, such as MVVM, right? MVVM, Viper, Clean, they didn't come about out of nowhere. People started to have issues with MVC. Their apps didn't scale well. Their code didn't scale well. And so what came about from that was new architectures or architectural design patterns. So let's go over model view view model. It's a bit of a mouthful. So in MVVM, the business logic is abstracted to an object called a view model. The view model is in charge of providing data to the view and updating the view when data changes. Traditionally, this is a good way to separate business logic from the view controller and offer a much cleaner way to test your code. So generally here, the view model is going to be one-to-one with the model as opposed to the view. And what the view model ends up being is this layer of business logic and presentation logic. And that's an important distinction from what the controller previously did, as the controller was more associated with the view and less so the model. So what you end up with, and this will kind of be the pattern as I go through each of the architectures, you're going to end up with these smaller and smaller pieces of bite-sized code. So in this case, maybe you have more models than views, so MVVM makes more sense, right? So the view model is responsible for persistence, networking, and business logic. ViewModel is going to be your data access layer, which is kind of awkward when it comes to something like Realm, since Realm is the data access layer. I will dig more into that, but with SwiftUI, you end up with a few extra bits that don't really make much sense anymore. This is just a quick diagram showing the data flow with MVVM. The view model binds to the view. The user inputs commands or intent or actions or whatever we want to say. The commands go through to the view model, which effectively filters and calculates what needs to be updated on the model. It then reads back from the model, updates the view, does that in sort of this circular pattern. So let's go over Viper. So Viper makes the pieces even smaller. It is a design pattern used to separate logic for each specific module of your app. So the view is your SwiftUI view. A view owns a presenter and a router. The interactor, that is where your business logic for your module lives. The interactor talks to your entity and other services such as networking. I will get back to this in a second. The presenter owns the interactor and is in charge of delivering updates to the view when there is new data to display or an event is triggered. So in this case, the breakdown, if we're associating concepts here, the presenter is associated with the view. It's closer to your view controller, and the interactor is more associated with the model, so it's closer to your view model. So now we're like mixing all these concepts together, but breaking things and separating things into smaller parts. So in this case, the data flow is going to be a bit different. Your view is going to interact with the presenter, which interacts with the interactor, which interacts with the entity, right? So you end up with this sort of onion that you're slowly peeling back. The entity is your data model. I'm not entirely sure why they didn't call it model. My guess is that Viper sounds a lot better than Vipamer. Doesn't really work. The router handles the creation of a view for a particular destination. This is a weird one. I'll touch on it a couple times in the talk. Routers made more sense when the view flow was sort of executed by storyboards and segues and nibs and all that kind of thing. Now with SwiftUI, because it's all programmatic, routers don't really make as much sense. That said, maybe in a complex enough application, I could be convinced that a router might elucidate the flow of views, but at the moment, I haven't seen anything yet. But that is what the router is meant to do anyway. This is a brief diagram on how Viper works. Sorry. So again, the view owns and sends actions to the presenter. The presenter owns and asks for updates and sends updates to the interactor, and the interactor actually manipulates the data. It edits the entity. It contains the data access layer. It'll save things, it'll load things, it'll update things. And then the interactor will notify the presenter, which then notifies the view. As you can see, this, for anybody that's actually used SwiftUI, this is immediately not going to make much sense, considering the way that you actually bind data to views. MVI, this is kind of our end destination. This is where we want to end up at the end of our journey. MVI is fairly simple. To be honest, it's closer to an ideal. It's closer to a concept than an architecture, to be honest. You have a user. The user has intent. That intent changes the model. That model changes the view. The user sees that, and they can keep acting on it. This has not really been possible previously. UIKit was fairly complex. Apps grow in complexity. Having such a simple thing would not have been enough in previous frameworks, especially unidirectional ones where a circular pattern like this doesn't really make sense. But now with SwiftUI, there's so much abstracted away with us, especially with Realm, especially with live objects, especially with property wrappers that update the view automatically under the hood, that update your Realm objects automatically under the hood. We can finally achieve this, which is what I'm going to be getting at in this talk. So let's go over some of those common concepts. Throwing around terms like view and presenter and model is really easy to do if you're familiar, but just in case anybody isn't, the view is what the user sees and interacts with. All architectural patterns have a view. It is the monitor, it is your phone, it is your whatever. It is the thing that the user touches that the user plays with. The user, the person behind the screen. The user actions can be defined as intent or interactions. Actions trigger view updates, which can trigger business logic. And I do feel the need to explicitly say that one thing that is also missing from this presentation, not all actions, not all intent will be user driven. There are things that can be triggered by timers, things that can be triggered by network requests, things that don't necessarily line up perfectly with the model. That said, I felt comfortable leaving it out of the talk because it actually doesn't affect your code that much, at least if you're using MVI. The model, so this term gets a bit complicated. Basically, it's the central component of the pattern. It's the application's data structure, independent of the user interface. It manages the data, logic, and rules of the application. The reason that this gets a bit wonky when describing it is that oftentimes people just speak about the model as if it was the data structures themselves, as if it was my struct foo with fields, bar, baz, whatever. That is the model. It's also an object. It's also potentially an instance of an object. So hopefully over this talk, I can better elaborate on what the model actually is. The presenter, so this is the presenter, the view model, whatever you want to call it. It calculates and projects what data needs to actually be displayed on the view, more often referred to as the view model, though in Viper it's presenter. Again, frameworks with two-way data binding kind of obviate the need for this. It is awkward to go to a presenter when you don't necessarily need to. So let's get to the meat of this. How does SwiftUI actually change the playing field? For starters, there is no controller. It does not really make sense to have a controller. It was very much a UI kit concept. Ironically or coincidentally, by eliminating the controller, this graphic actually ends up looking a lot like MVI. The user manipulates the model through intent. The model updates the view. The user sees the view, goes around in a big circle. I will touch on that a bit more later, but MVC really doesn't make as much sense anymore if you consider it as the new school MVC. MVVM added a few nice green arrows here. ViewModel doesn't really make sense anymore. Again, this is the presentation layer. When you can bind directly to the data, all you're doing by creating a view model with SwiftUI in a two-way data binding framework is shifting responsibility in a way that creates more code to test and doesn't do much else, especially these days where you can just throw that business logic on the model, right? If you were doing traditional MVVM with SwiftUI, the green arrows would be going from view to view model, and you could create the same relationship. It's just extra code. It's boilerplate. Viper, a lot of confusion here. Again, not really sure that the router makes a lot of sense. I can be convinced otherwise. Presentation view, the presenter doesn't really, again, make sense. It's basically your view model. Interactor also doesn't make sense. It is, again, because the view is directly interacting with the model itself or the entity. This piece is, again, kind of like, what are you doing here? There's also an element here that as you keep building these blocks with Viper, and it's both a strength and weakness of Viper. So the cool thing about it, you end up with all these cool little pieces to test with. But if a 10,000 line controller is spaghetti code, 10,000 lines of Viper code is ravioli code, right? You like these little pieces end up being overwhelming in themselves, and they end up, a lot of them do nothing but control a lot at the same time. We'll get more into that when I show the actual code itself. And here's our golden MVI. Nothing changes. This is the beauty of it. This is the simplicity of it. User interacts, changes the model, changes the view ad infinitum. So now let's actually compare these with code. So the app that we will be looking at today, Apple came out with a Scrumdinger app to show off SwiftUI. It is basically an app that lets you create scrums. If you're not familiar with the concept of a scrum, it is just it's a meeting, it's a stand-up where people briefly chat and update and so on and so forth. I could go into more detail, but that's not what this talk is about. So we took their app, we added Realm to it. And we also then basically wrote it 3 different times, one in Viper, one in MVVM, and one in MVI. This will allow us to show you what works and what doesn't work. Obviously, it's going to be slightly biased towards MVI. And of course, I do feel the need to disclaim that this is a simple application. So there's definitely going to be questions of like, how does this scale? How does MVI actually scale? I can address those if they are asked. If not, it should become pretty clear why I'm pushing MVI as the go-to thing for SwiftUI plus Realm plus the Realm property wrappers. Yeah. So let's compare the models. So in Viper, this is your entity, right? So it contains the scrums. So the daily scrum is going to be our like core data structure here. It's going to contain an ID, it's going to contain a title, it's going to contain attendees and things like that. But the main thing I'm trying to show with this slide is that the entity loads from the realm. It loads the daily scrums, which for those that have used Realm, you already kind of know this is a bit awkward because everything with Realm is live. Those daily scrums, that objects, realm.objects, daily scrum.self.map. So if you were to just save out those objects, those results are always updating. Those results read and write directly from the persistent storage. So loading from the database is already an awkward step. So otherwise, you can push new scrums, you can update scrums. Again, what this is doing is creating a data access layer for a database that is already the data access layer. But this is the idea of, either way, this is the idea of Viper. You are creating these abstractions to better organize how things are updated, pushed, loaded, etc. MVVM, the model is still more classically the data structure itself. I will show the actual view model in another slide. This should look a bit more similar to probably what you'd be used to. Actually, there's probably a mistake here. The color shouldn't be there because that should be in the view model. But for the most part, these are your properties, right? The big difference here between MVI will be the fact that, again, you're creating this access layer around the realm where you're going to actually pass in the view model to update the scrum itself and then write to the realm. It's even possible that depending on your interpretation of MVVM, which again is something I should have actually said earlier in the talk, a lot of these architectures kind of end up being up for interpretation. There is a level of subjectivity. And when you're on a team of 20 people trying to all architect around the same concepts, you might end up with some wishy-washy view models and models and things like that. MBI, this is your model. That is the Realm database. And I'm not actually being facetious here. If you consider Realm to be your data access layer, to be your persistent storage, to be the thing that actually syncs data, it holds all your data, it maintains all of the state, which is kind of what the model is supposed to do. It maintains state. It maintains the entire flow and state of your application. That is what Realm can be if you use it as it's intended to be used. So let's go over what the views actually look like depending on your architecture. Spoilers, they look very similar. It's what's happening under the hood that actually really changes the game. So in this case, you have the scrums view. The object that you have on the view, you'll notice this does not, even though this app uses Realm, it is not using the Realm property wrappers because you are presenting the presenter. Kind of makes sense, I suppose. But you're going to show the scrums from the presenter, and you're going to pass around that presenter around this view to be able to interact with the actual underlying model, which is the daily scrum class. You'll also notice at the bottom, which is, I suppose, a feature of Viper, each view has a presenter and potentially each model has an interactor. So for the edit view, right? So I have this Scrum app. I want to edit the Scrum I have. I want to change the title or the color of it or something like that. I want to add attendees. For Viper, you have to pass in a new presenter. You have to pass in a new interactor. And these are going to be these bite-sized pieces that, again, interact with the view or model depending on which thing you're talking about. How am I doing on time? Cool. So this is the actual like edit view now that I'm talking about. So the edit view has that presenter. That presenter is going to basically give the view all of the data. So length and minutes, title, color, attendees, things like that. They're all coming off the presenter. You can see over here where I'm circling, you would save off the presenter as well. So when you're done editing this view, you save on the presenter. That presenter is actually going to then speak to the interactor, and that interactor is going to interact with the Realm database and actually save out that data. Again, the reason that this is a bit awkward when using Realm and SwiftUI at least is that because you have live objects with Realm, having these intermediary layers is unnecessary abstraction. So this is MVVM, and now we actually have the video of the view as well on the right side. So instead of a presenter, you have a view model, right? Now you're seeing all the terms come together. You're going to read the view models off of the view model for each view. So for the detail view, you're going to pass in the detail view model. For the edit view, you're going to pass in the edit view model. And this edit view model is going to take a scrum, and it's going to read and write the data to that scrum. This is for MVI now. So MVI is going to look a little different. The view code is slightly larger, but there are no abstractions beyond this. So in this case, you have your Realm property wrapper. You have observed results. This is going to be all of the daily scrums in your Realm database. it is going to live update. You are not going to know that it's updating, but it will notify the view that it's updating. So if a daily scrum was added, say you have realm sync, a daily scrum is added from somebody else's phone, view just updates. There is no other code you have to write for that. Below that, you have a state realm object, which is new scrum data. So in this case, this is a special case for forms, which is a very common use case. That scrum data is going to be passed into the edit view, and it's going to be operated on directly. So the main added code here, or the main difference in code, is this bit right here, where we actually add the scrum data to the observed results. So somebody following MVVM or Viper religiously might say that's terrible, right? Why are you doing business logic in the view like that? Why would that happen? This is a direct result of user action, right? A user hits the done button or the add button. This needs to happen afterwards. Technically, if you really wanted to, you could abstract this out to the model itself. You could put this on an instance of new Scrum data and have it write itself to the realm. That is totally valid. I've seen people do that with MVI, SwiftUI, and Realm. In this case, it's simple enough where those layers of abstraction don't actually add anything beneficial. For testing, this would be, you'd want to test this from a UI test anyway. And the reason for that is that we test that the Scrum data is added to the realm, we being Realm, right? I suppose there's a level of trust you have to have with Realm here that we actually are testing our code. I promise that we are. But that's the idea, is that all of this appending data, all of this adding to the database, the data access layer, that's tested by us. You don't have to worry about that. So yeah, why is this view larger than the MVVM view? Because the interactor logic has been shifted to the ViewModel in MVVM. There's no extra logic here. It's all there. But for MVVM, again, it's all been pushed back. The responsibility has been shifted slightly. MVI, this is actually what the edit view would look like. There's no abstractions here. You have your state realm object, which is the daily scrum that's been passed in from the previous view, and you bind the title directly to that. So if you look at the right side video here, as I change the Cocoa team scrum to Swift team scrum, it's a mouthful, that is updating to the realm, that is persisting. And if you were using realm sync, that would be syncing as well. But there is no other logic here. That is just handled. Hopefully at this point, you would be asking yourself, why add the extra logic? I can't give you a good reason, which is the whole point of this talk. So let's go over the ViewModel and persistence, or dig in a bit deeper. So this is our actual realm object. This is the basic object that we have. It's the POJO, the POSO, whatever you want to call it. It is your plain old Swift object. In this case, it is also a realm object, has an ID. That ID would largely be for syncing. If you had, say, if you weren't using realm sync and you just had a REST API, it would be your way of identifying the scrums. It has a title, which is the name of it, of course, a list of attendees, which in this case, for this simple use case, it's just strings, it's names, it's whatever. The length of the scrum in minutes, and the color components, which depending on which thing you're using is actually pretty cool. And this is something that I probably won't have time to fully dig into, but you can use Realm to manage view state. You can use Realm to manage app state. If, say, you're scrolling in a view and you're at a certain point, and then you present another view, over that, maybe it's a modal or something, and the phone dies. That sucks, right? You can open up the app when the phone turns back on, if they've charged it, of course. You can bring them back to that exact state if it's persisted in the realm, right? In the case of color components, the cool thing there is that you can have a computer variable, which I'll show after, that will display directly to the view as a color. And with that binding, the view can also then change that color. The model can break it down into its components and then store that in the realm. So let's actually skip the presenter in that case, because we were actually on the edit view, which I think is the more interesting view to talk about. So this is the edit presenter for Viper. This is your view model, this is your presenter. As you can see here, it owns the interactor, and it's going to modify each of these fields as they're modified, right? It's going to fetch them, it's going to modify them, it's going to send updates to the view because it can't take advantage of Realm's update, it can't take advantage of Realm's observe or the property wrappers or anything like that, because you are creating this separation of layers. Same here with colors, it's going to grab everything. When you actually add new attendees, it's going to have to do that as well. So as you can see, it just breaks everything down. This is the interactor that's actually now going to talk to the model. This is where your business logic is. This is where you could validate to make sure that, say, the title's not empty, that the attendees are not empty, that the length of time is not negative or something like that. And this is also where you'd save it. This would be the router, which I didn't really know where to put this. It doesn't fit in with any other architecture, but this is how, say, you would present views with Viper. Let's leave that up for a sec. And for anybody that's used SwiftUI, you might be able to see that this is a bit odd. So this would be your top level view model for MVVM. In this case, you actually can somewhat take advantage of Realm if you wanted to. Again, it depends on how by the book you are approaching the architecture as. So you have all your scrums there, you have what is and isn't presented, you have all your view models there as well, which are probably going to be derived from the result of scrums. It's going to manage the realm, it's going to own the realm, it's going to own a network service potentially. You're going to add realms through here, you're going to add scrums through here, you're going to fetch scrums through here. It controls everything. It is the layer that blocks the data layer. It is the data access layer. And this is going to be your view model for the actual daily scrum. This is the presentation layer. This is where you're seeing, right, so you get the scrum title, you change the scrum title. You get the scrum length in minutes, you change the scrum length in minutes. You validate it from here, you can add it from here, you can modify it from here. It also depends on the view, but to avoid repeating myself, this would be the edit view with the view model. So instead of having the realm object here, as you saw with MVI, you'd have the view model. The two-way data binding is actually going to change the view model, right? And then at the end, you can update. So things don't need to be live necessarily. And again, the weird thing here is that with Realm's live objects, why would you want to use a view model when you have two-way data binding? And just to, oh, my laptop fan has just gotten very loud. This is the path to persistence with MVVM as well. So user intent, user interaction, they modify the view in whatever way they do it. It goes through the presenter, which is the daily scrum view model. This is specifically coming from the edit view. It goes to the presenter, it changes the daily scrum model, which then interacts and persists to the realm. Given anybody that's used Realm, again, to repeat myself, this is a strange way to use Realm considering what Realm is supposed to be as your persistent storage for live objects. So MVI, what is your presentation layer? You know, there's no VM here, there's no extra letters in here, so what do we actually do? In MVI, the presentation layer is an instance of your data model. It is an instance of these simple structures, right? So in this case, this is the actual daily scrum model. You can see on here the color thing that I was talking about before. This color variable is going to bind directly to the view. And when the view updates, it will update the model, it will persist to the realm, it will sync to MongoDB realm, right? It will then get the color back, show it in the view, etc. And for business logic, that's going to be on the instance, right? This could be in an extension, it could be in an extension, it could be in a different file. There's ways to organize this that obviate the need for these previously needed abstractions in UIKit. Right, so this is an actual implementation of it, which I showed earlier. You have your state realm object, which is the auto-updating magic property wrapper in SwiftUI. You have your daily scrum model. An instance has been passed in here. So when we actually write the title down, or type the title, I suppose, right, because it's on the phone, it is going to update, sync, persist, etc. MVI is a much shorter path to persistence because we are binding directly to the view. User makes an action, action modifies the view modifies the actual state. View modifies the realm, modifies the daily scrum, syncs, etc. Why MVI is not scary, not as in all capital letters, because I'm super serious, guys. So MVI is lightweight. It's nearly a concept as opposed to a by-the-book architecture. There are standards and practices you should definitely follow. Your business logic should be on the actual instance of the data model, right? The two-way data binding should be happening on the view itself. There's some wiggle room, but not really. But the implication is that the view is entirely data-driven, right? It has zero state of its own, bar a few dangling exceptions like things being presented, like views being presented or scroll position or things like that. And all UI changes come from changes in the model, which again, leveraging Realm, the model auto updates and auto notifies views anyway. So that is all done for you. And SwiftUI, though imperfect, does come very close to this ideal. View state can even be stored and persisted within the guidelines of the architecture to perfectly restore user state in the application, which ties back to the case I gave of somebody's phone dying and wanting to reopen right to the exact page that they were at in the app. So when considering the differences in SwiftUI's 2A data binding versus UIKit's unidirectional data flow, we can rethink certain core concepts of at least MVVM and to an extent Viper. And this is where rethinking the acronyms or abbreviations kind of comes into play a bit. It's a light spin, but I think for those who actually, let's say you're on your team of 20 iOS developers and you go to the lead engineer and you're like, I really think we should start doing MVI. And they're like, well, we've been doing MVVM for the past 5 years, so you can take a walk, right? In this case, just rephrase MVVM, right? Rephrase Viper. In this case, your model becomes the realm database. It is where you persist state. It is the data access layer. The view is still the view. That one doesn't change. The view model, again, just becomes an instance of your realm object. You just don't need the old school view model anymore. The business logic goes on that. The transformation goes on that. It is honestly a light shift in responsibility, but it prevents having to test so much extra boilerplate code. If the goal of MVVM was to make things easier to test in previous iterations of iOS development, it no longer applies here because now you're actually just adding extra code. Viper concepts can be similarly rethought. Again, your view is your view. Your presenter and interactor are the view model, right? Your entity is the model, and your router is an enigma to me. So I'll leave that one to the Viper devs out there to figure out. It looks like we have enough time for the extra slides that I have here before the Q&A. So just a bit of like networking code. This is really basic stuff. It's not very good code either. So in this case, we're just going to fetch the scrums from a third-party service, right? So we're not using Realm Sync in this case. We have some third-party service or our own service or whatever that we call in. If we want those to show on the view, we're going to have to notify the view. We're going to want to cache those maybe. So we're going to add those to the realm. If they actually do have IDs, we want to make sure that our update policy does not overwrite the same scrums or anything like that. For updating, and this is Viper, by the way, for updating, similarly, we're going to pass the scrum to the interactor. That scrum is going to get sent up to the server. We're going to make sure that that scrum is then added to the realm. Depends on what we're updating. If we've updated it properly and using realm as realm is intended to be used, you should not have to re-add it to the realm. But if you are following Viper by the book, you need to go through all the steps of reloading your model, saving this appropriately, and updating the view, which again is a lot of extra work. Not to mention here as well that this does not account for anything like conflicts or things that would happen in a real world scenario, but I will get to that in a later slide. So for MVVM, in this case, the networking is likely going to be on the view model and go through, again, some kind of service. It's very similar to Viper, except that it's on the view model. We're going to fetch, we're going to add to the realm as a caching layer. And because we're not using the realm property wrappers on the view, we're using the view model, we have to update the view manually, which is the object will change.send. So for MVI, it's similar, but again, slightly different. Because the realms are on the view this time, the main difference here is that we don't have to update anything. That results from before the observed results, that's going to automatically update the view. And for the update case, you shouldn't really have to do anything, which is the big difference between the other two architectures. Because you're using live objects, everything should just be live. And because in MVI, the business logic is going to be on the data models themselves, or the instances of the realm objects themselves, these methods are going to be on that you update using yourself, which is here. And the cool thing, if you're using MongoDB Realm Sync and you're thinking about networking, you don't have to do anything. And again, not being facetious, that's handled for you. If you're using your persistence layer and thinking about sync, when you actually open up the realm, those scrums are going to be pulled down for you. They're going to hydrate the realm. If somebody on their phone updates one of the existing scrums, that's going to be automatically there for you. It is going to appear on your view live without you having to add any extra code, any extra networking or whatever. Similar removal, and of course, Realm Sync also handles things like conflicts where if I'm updating the Scrum at the same time as somebody else, the algorithm on the back end will figure out how to handle that conflict for you. And your realm, your persistence layer, your instances of your data models as well, which is another cool feature from, because remember that they're live, they will be up to date, they will sync to the views, which will then have the most up-to-date information without you adding any extra code. I would love to go into this more. So for my next talk, I think the thing I want to do, and of course I'd like to hear from everybody if they'd be interested, but the thing I want to do is to show a more robust, mature, fully fledged application using MVI, MongoDB Realm Sync, SwiftUI, Realm, and the property wrappers, which we can talk about more in the Q&A, but that's my goal. I don't know when the talk will be, but hopefully sooner than later, right? And then finally, the last bit of slides here, actually testing your models. So for MVVM, you actually have to test the view models. You're going to test that things are writing to the database and reading from the database appropriately. You're testing that the business logic validates correctly. You're testing that it calculates view data correctly. You're testing out all of these calculations that you don't necessarily have to test out with other architectures. Viper, it's going to be the same thing. You're just literally swapping out the view model for the interactor and presenter. But for MVI, colors are a little messed up there. You're really just going to be testing the business logic on your models. You're going to create instances of those realm objects and make sure that the business logic checks out. For all of these, I would also highly recommend that you write UI tests. Those are very important parts of testing UI applications. So please write those as well. And that's it. Thank you, everyone. That is all for the presentation, and I would love to throw this back to Ian and Shane so that we can start a Q&A.
Excellent. Thank you, Jason. That was great. I learned a lot in that as well too. So do appreciate that. I was watching the comments on the side, and thank you for the likes of Jacob and Sebastian and Ian and Richard and Simon who've raised some questions. There's a couple that might come in there. But above all, they've been answered by Lee and also Alexander Stigson, who, for those of you who don't know, and he'll kill me for saying this, is the founder of Realm, and he's on the chat. So if you've got some drop it in there. He's going to kill me now. I'm dead.
Yeah.
So I think for anybody, as I said at the beginning, we can open this out and turn on your camera and microphone if you want to ask a question directly. There's no problem if you don't want to come on camera. You can throw it into the chat and I'll present it to essentially Jason and Ian and we'll discuss it. So I think while we're seeing if anybody comes in there, for this Scrumdinger example, Jason, are we going to put our Realm version up on a repo somewhere that people can play around with?
Yes, we will. It is not going to be available today, unfortunately, but we are going to do that in the next, hopefully, few days. So I will, I guess we'll figure out a way to send out a link to all of these when that time comes.
So we have a question from Jacob. What thoughts do you have on using MVI for more mixed scenarios? For example, an app where some views operate on the database while others use something like a REST service.
Where is the question, by the way?
Have the chat tab open. They're just appearing in the chat there to give you some heads up. Most of the others were answered by Alexander and Lee, which is great. Really appreciate that. But so looking at the bottom of the chat there, Jason, if you want to see them come through.
I see. Jacob. Yeah, so I hope I was able to touch on that a bit at the end. For views that need to talk to some network service, I would recommend that logic, again, no different than MVVM or Viper, that logic, which I would consider business logic, even though it's talking to a REST service, it just goes back on the instance of the object itself. In certain cases, I think, let's say you're fetching all of the daily scrums from the server, I would make that a static method on the instance of the data object, which is mainly for organizational purposes, to be honest. But I don't think that it needs to be specially considered beyond that. I'm sure in extremely complex cases, more questions could be asked, but I would probably need to see a more complex case to be able to.
I think one of the themes while you were presenting with the different architecture patterns is that a lot of the argument here is that we are eliminating boilerplate code. We're eliminating a lot of the code that a developer would normally need to write in order to implement MVVM, or there was a talk of MVC as massive view controller, right? And some of the questions around MVI were, do we have the risk of also maybe inflating the model as well here? Does some of that boilerplate code now go into the model? How would you kind of talk to that a little bit of putting extra code into the model now to handle some of this?
As in, like, how to avoid this massive inflation of your model?
Exactly.
The same issue.
Like, are we just moving the problem around, or does some of this kind of eliminate some of that boilerplate?
I mean, to be honest, each one of these architectures is moving the problem around.
That's fair. I guess that's why it's a contentious issue, right? You have your opinions, and at some point, it's where do you want to put the code, right?
Right. Which is why, like, there is no best solution, and there is no best answer to your question either. The reason that I'm positing MVI here is not necessarily about code organization, which is always going to be a problem, and it's going to be unique to somebody's application. If you have a crazy amount of business logic on one of your realm objects, you probably need to break up that realm object. That would be my first thought. It might not be true for each case. I've seen applications where people have 40 different properties on their realm object and a ton of logic associated with it. I personally would prefer to see that broken down a bit more. You can then play devil's advocate and say, well, okay, then you end up with the ravioli code that you were talking about from before, right? So it's this balancing act, right? The main reason I'm positing MVI as the go-to architecture is less about code organization and more about avoiding unnecessarily boilerplate and having to, frankly, test more code that doesn't really do much.
That's a fair answer. And a couple questions that are coming in here. There's one question at the beginning asking about the block pattern, which, watch out, sounds like we have a Flutter developer in here. But the block pattern is very much about event streams and passing kind of events back and forth, which although we have the property wrappers, we've done a lot of the work under the hood. And then there was another question on combine. So maybe you could talk a little bit about our combine support and some of the work that we've done with property wrappers to integrate with that.
Sure. So we've basically added extensions to each of our observable types, which in the case of Realm is going to be objects, lists, backlinks, results, which is basically a view of the table that the object is stored on, which can be queried as well. And then by effect through objects, you can also observe individual properties, right? We have added support to combine, so you can do that through the flow of combine, right? To get those nice chains of observations, to be able to map data how you want it, to sync it at the end and all that kind of thing. Under the hood, our property wrappers are hooking that observation logic into SwiftUI. Those property wrappers themselves have information on that so that when a change happens, it notifies the view. To be honest, that is actually, some of that is not through combine, some of that is just through standard observation. But I think the end mechanism where we actually tell the view, this thing needs to update, that is through, I guess, one of the added combined features, which is the publisher for object changes, right? We notify the view, hey, this thing is updated. So yeah, there's full combine support for Realm is the short answer as well.
Cool. There was a question hiding away in the Q&A section as well too. Does @state Realm object sends Realm sync requests for each keystroke?
It would, but surprisingly enough, that is actually not as heavy of an action as you might think. We've had a lot of debate about this as well, because that is one of the first questions asked when people see the data being bound to a text field. It's really not that heavy. If you are that worried about it, or something is, or maybe this is just some application that you want to work in the tundras of Antarctica, and maybe you don't want to have to worry about things like network connection or something, I would consider using a draft object, something that is not being persisted to the realm, and then at the end, when you are ready to persist it, you can persist it. classically, that would have been the view model, but now you can just use an instance of a non-persisted realm object.
Yeah, that was another question as well. I believe, Simon, you had a question regarding draft objects and having, and so when you say draft objects, you're saying a copy of the realm object in memory. Is that correct? Or maybe you can go into that a little bit.
It could be a copy. That would be the way to handle an existing object that you want to modify if you don't want to set it up on every keystroke. For form views, in this case, let's say it's a form where it doesn't exist in the realm, you can just do an unmanaged type. And to answer Simon's second query there, yeah, it could also be managed by a local realm. That is also perfectly valid. That is another approach. And if I recall, Simon, were you working on the workout app? Is that?
I believe he was.
I don't know. Yeah. I played around with that. That is a good app example for having a lot of forms where, yeah, maybe you don't want to persist on every keystroke. Maybe you even want something like specifically, and I believe this might have even been the advice that I gave you on the forums. Yeah, store a draft object in a local realm. It could be the exact same object. It could be a different model that is just called, let's say you want to save your workout and it has sets and reps and whatever. You might have a workout object stored in the synced realm, and then you might have a workout draft object stored in a local realm, and you can handle it that way as well.
Great. Does anybody want to come on screen with us? Turn on the camera, turn on the mic, join us. If you do, just ping in the chat. I'll jump in. I'll turn that right on for you. Richard had a question further up, but it was more kind of advice, more so than a question per se, Jason. It's nice to show some examples of how you would blend MVI with wrapped view controllers. He's saying that rewrites are iterative and involve hybrid systems, was the other point he made.
Right. Yeah, that would be a great concept for another talk, because yeah, you're totally right. Like, it's really easy for me to come in with a baseball bat or cricket bat or whatever and just knock everything down and say use MVI. But in reality, of course, yeah, you want to incrementally migrate to something. You never want to do well, not never, but most of the time you don't want to do a total rewrite.
Yeah, a total rewrite would be a sticky wicket, I think, right? So, is that the term for cricket? So we have another question here on realms auto sync, and the question from Sebastian is: Can we force trigger from an API sync? And actually, I can answer this one. So yes, you can. There is a suspend and resume method for realm sync. So if you really want to be prescriptive about when realm syncs and doesn't sync, you can control that in your code.
Perfect. And Parth asks, is there any learning path available to get started with Realm? Well, we've got a few. Obviously, our docs is a good place to start if you go looking there. But the other thing too is come on to, and this is the plug, developer.mongodb.com. And from there, you can get to our developer hub for articles. You can get into our forums to ask the questions of the engineers who are on here, and indeed our wider community as well too. But we're also very active where our developers are. So in GitHub, Stack Overflow, etc. as well too. There's comments and questions whizzing around there. Jason, is there anywhere else to go and grab information on getting started with Realm? Yeah. Well, I mean, obviously, this is the place to go as well too. I know we went in at a high level and a lot of this here, and maybe it's not obviously the beginner stuff, but we intend to run these as often as we can, certainly once or twice a month going forward, resources permitting and time permitting for everybody too. So, as Ian said, I think at the beginning, tell us what you want to hear in meetups like this as well too, because we want to engage with our community, understand where you're at, and help you resolve your problems with Realm as much as possible.
Absolutely.
So Ian has another one in here. Ian Dundas, thank you, Ian. How to move a local realm into sync. Just copy the items manually from one to the other, or is there a switch you can throw to make the local one a synced one?
Yeah. So we.
Ian, I feel like that would be a
Yeah,
good
so we
one for
do
you.
get this feature request. It is something that is on my list, my list of product backlog. Definitely something I want to add, and we just need to put a product description together. Another thing on my backlog. But yes, right now, what you would do is to open the local realm, iterate through all the objects, copy them over into a synced realm. The issue here is that a synced realm has to match the history of the MongoDB realm, the sync server on the side. So the histories have to match, and a local realm doesn't have that history. So it kind of breaks the semantics of conflict resolution. In the future, we would like to give a convenience API to do this very simply for the user. And so hopefully we can solve that use case for you.
Good. Well, Ian has responded to say that makes sense, and indeed it does, as always. Something else for your task list then, so Ian, definitely.
Absolutely.
I'm trying to scroll back through here to see, did we miss anybody? If we did miss anybody, do let me know. I noticed a comment further up from Manav, which was great to see, which is these sessions turn out to be the best use of my time. And that's what we're looking for, that validity from our community that this is worth the time. Jason puts a ton of effort into getting this prepared, as does Ian, and pulling it all together. Those examples don't write themselves. And indeed, the wider team, the COCA team with Jason as well, had put effort into putting this together. So it's great to see that these are very beneficial for our community. So is there anything else, any other questions? I suppose throwing it back out to you, Jason, what's next? What's on the roadmap? What's keeping you busy at the moment? Ian, what are we planning for later on? You're not going to say you can't tell, right?
Ian, what are we allowed to do?
Yeah, I mean, for iOS specifically, I think maybe Jason, we were talking about group results. I know we had a scope the other day to do that. We're also talking about key path filtering. These are kind of developer improvements for some of the APIs that we have that are very iOS specific. So I don't know, Jason, if you want to talk to a couple of those things, that would be great.
Sure, yeah, and I'll talk about some of stuff that hopefully we'll get to next quarter as well. So group results is something we actually have to figure out, and ironically actually ties more to UIKit and basically how to better display realm data on table views. But we are still figuring out what that looks like. Key path filtering is nice. It just gives you granular observation for the properties that you do actually want to observe and listen to on objects. Some of the other things that we've begun prototyping, and I don't think it's, I can't promise any dates. Also, by the way, Realm is open source, so all of this stuff that we're talking about, you can go on our branches, you can see our pull requests. So some of the stuff that we're prototyping right now, async writes, which is a pretty common use case for writing data to Realm asynchronously. We're toying with that. We're toying with another property wrapper called auto open, which will hopefully simplify some of the logic around MongoDB Realm logging in and async opening the realm. Basically, the goal of that project is so that, let's say you're downloading a synced realm with a ton of data in it, as opposed to having to manually open the realm, notify the view that it's done, etc. You'll again just use a property wrapper that when the realm is done downloading, it will notify the view that that's occurred. We're also talking about updating our query syntax. That one I'm particularly excited about. Again, no dates promised, but it will basically be, as opposed to having to use NS predicate to query on your realm objects, you would be able to instead use a type-safe key path-based query syntax closer to what Swift natively uses.
Yeah,
so.
Absolutely. And we got some new types coming down the pike as well, right? We have a dictionary type for more unstructured key values, as well as a set we're looking to introduce very shortly, and a mix type as well, which I believe we have a different name for that, don't we, Jason?
Yes, it will follow
any realm value.
Realm
there you go.
Hints at what that does. Yeah, yeah. Any realm value that's left in the realm. Also,
yeah, so we had a lot of feature requests for full text search. And so if you have, let's say, an inventory application that has a name and then a description, 2 fields on an object, and that's a string field, we have just approved our product description for full text search. So you'll hopefully be able to tokenize, or we are working towards tokenizing that string field. And so then you can search it, search that string field, search the actual words in that string field to get a match at index level speeds. So hopefully that will help individuals, especially when they're offline, to search string fields.
As Richard said, dictionary would be huge. Yeah, we're excited about that one. We're probably going to call it map. So yeah, that's an exciting one coming down the pipeline.
Oh, Ian squeezing in a question there, a feature request actually. Ability to open multiple sync realms targeting multiple partition keys.
Yeah. So we are actively working towards that. I don't know how many people are familiar with Legacy Realm. I recognize a couple faces here, but we did have something called query-based sync, and we are looking to have a reimagination of that, a query-based sync 2.0, or we're also calling it flexible sync, which will have a very analogous usage where you'll be able to send queries to the server side, have those queries run, and return the result set down to the client. And this will remove the partition key requirement. And so, yes, we are definitely working on that, and it's definitely needed for our sync users for sure.
Excellent. That got a yay and a cool emoji from Ian. Thank you, Ian. Appreciate that. Excellent. I think that probably, look, we're just after the hour, or 2 hours for those of you that joined at the earlier start time that Bevy decided we were going to do this at. For wrap up from me, from an advocacy point of view, we love to reach out to the community. So I'm going to plug again, developer.mongodb.com. Please come on board there to our forums and our developer hub where we write about Realm content all the time. We want to grow this community, so live.mongodb.com will lead you to the Realm global community, where if you sign up, if you haven't already, if you sign up, you'll get instant notification of any of these future meetups that we're doing. So, you know, they're not all Swift. We're covering all of our other SDKs as well too, and then we have general meetups. So please sign up there, share the word, and also on Twitter, the @Realm Twitter handle. If you enjoyed this, please share that on Twitter with everybody. We love to see that feedback come through, and we want to be part of that community. We want to engage on Twitter as well too. So our developer hub, our forums, and Twitter, and then obviously, as Jason mentioned, the Realm SDKs are open source. You can contribute on our repos if you like. We love to see the participation of the wider community as well too. Ian, anything to add?
No, it's just it's really great to see so many people joining and giving great questions. And so thank you so much for coming. And we love to see your feedback. So please try out our new property wrappers. Give us feedback. We want to hear from the community. And thank you so much, Jason and team, for putting this together. It's been a pleasure.
Indeed. Excellent.
Yeah,
thank you, everyone.
For joining.
Take care.
Thank you. Have a great week. Bye.